Right, good day everyone. You're welcome to another exciting video lesson on my YouTube channel. Now, in today's video, we're going to be looking at, just as you saw in the thumbnail, we're going to be looking at 20 questions on the Chatelier's principle, and that is what we are starting with. 20 questions on the Chatelier's principle. So after these two questions, we'll move to other questions. All right. So question one it says the chemical reaction A plus B to give us C plus D. More of B is formed A if the concentration of A is reduced. Now, this one has to do with concentration. Please, if you have not watched my previous video on explanations involving the Chatelier's principle, please do it to go and watch that video. All right, do it to watch that video. Very, very important. Okay, so now when it comes to concentration, I told you guys from that video, I said if you want to favor the right, all right, you can either remove from the right or you add to the left. Addition favors opposite side. Subtraction favors that same side. So if I add to here, I am favoring here. If I add to here, I am favoring here. If I remove from here, I am favoring here. If I remove from here, I am favoring what? This side. So the answer to this question becomes A if the concentration of A is reduced. That's wrong. If the concentration of A is reduced, this side will be favored, not D. Remember, D is at the, they said more of D is formed. These are the rights. So A is out. B, if the concentration of B is reduced, B is out. Right? So talking about those two. Now C, if the concentration of C is reduced, this would have been correct. But if you look at option D has a more accurate answer. So this, if D is continuously removed from the reaction mixture, that is correct. So as D is being formed, if you remove it, that's reduced. If you are removing D as it's being formed, more of D will be formed. So the most accurate to go with is option D. If the concentration, if D is continuously removed from the reaction mixture. Question 2. In the reaction N plus N to give us P delta H equal to plus QAG. So now what this is telling us is that this reaction is what? Endothermic, because it is positive. So it means that the forward reaction is endo and the backward reaction is what? Exo. Now, which of the following would increase the concentration of the product? What will increase the concentration of the product? So what will lead to the increase in concentration of P? A, decreasing the concentration of N. Remember, when you decrease from one part, that same part is favored. P is in our right, N is in the left. So if you remove from N, the left will be favored. So A is not part of it. Then B, increasing the concentration of P. If you increase the concentration of P, as you add to this, the opposite side is favored from concentration. Don't forget, when you add to one side, the opposite side is favored. When you add to this side, this other side is favored. So, B is out. C, adding a suitable catalyst. Please, this is not part of it. I want to state clearly that addition of catalyst, please take note, addition of catalyst has nothing to do with the Chatelier's principle. It has nothing to do with the equilibrium position of a reaction. Catalysts have no effect in the equilibrium position of a reaction. Please take note of that. Very important. So C is out of it. Catalyst does not have any effect on the equilibrium position. Then option D, obviously that's the answer. Now, why is D the answer? Why is D the answer? Remember, positive endothermic. So it means that the forward reaction is endo, the backward is what? Exo. So increase the temperature favors what? Increasing the temperature favors endothermic reaction. Decreasing favors exo. So because P is at the right hand side and the right hand side is our endo, so when we increase the temperature, P, which is the endo part of the reaction, is what? Favored. Alright, so the concentration of P would increase. So the answer is D. Okay, class, now let's look at question 3. It says A plus F to give G plus H. The backward reaction is favored if the reaction of, now we're looking at the backward reaction. So which among these options is going to favor the backward reaction, which is the left? That's the backward reaction. Forward, talking about the right. So option A, E is reduced. This is obviously the answer, okay? Because when you reduce from E, E is at the back side, so the left side. So when we reduce from E, that same side is favored. So the answer is option A, but the answer is option A, but let us analyze other questions. So B, G is reduced. If you reduce G on the right side, this right is favored, so the forward side is favored. If you increase F, the opposite side is favored. So this is out of it, this is out of it. And if you increase E, the opposite side is favored. So the option that will favor the backward reaction, which is the left hand side, is E is reduced. So when E is reduced, this side, which is the left hand side, right, the left hand side, that side is favored. Alright, now let's look at question 4. You have this SO2 plus this minus 189 kilojoules. The equilibrium constant for the reaction above is increased by, alright, so A, increasing the pressure of the system. Now, in order to know if pressure can affect, there are two things you need to look at for. First of all, alright, no, there's only one thing you need to pay attention to, right? Now, you pay attention, are all of them gases? So this is a gas, this is a gas, this is a gas. So all of them are gases, meaning pressure can have effect on this reaction. So remember, temperature is minus 189. So that means minus. Therefore means that what our front reaction is what? Exo. And our backward reaction is what? Endo. Okay? So endo and exo. Alright. So the equilibrium constant for the reaction above is increased by, how will the equilibrium constant be increased? For an exothermic reaction, exo, alright? So A, increasing the pressure of the system. Is it only increasing the pressure? Alright, let's leave option A. B, increasing the temperature of the system. This one is totally out of it. Because when they tell you, the equilibrium constant for the reaction is increased, equilibrium constant increased, that means going to the forward direction, because our delta H is minus, so we are paying attention to minus. That simply means we are talking about what? The exo, which is the forward direction, right? So B is out of it. When you increase the temperature, it's going to take it backward, alright? It's going to take it backward. So it's going to decrease the equilibrium constant. So it is out of it. C, increasing the surface area of the vessel. This one is totally out of it. And then D, the addition of the catalyst. I told us, addition of the catalyst. Catalyst has no effect on the equilibrium position of the reaction. So catalyst is out of it. Increasing the surface area is totally off it. So the option that makes a lot of sense is option A, increasing the pressure of the system. Now, how do I know that increasing the pressure of the system can take it to the right hand side? It's very easy. Now, how many number of moles do you have at the left and at the right? Now, this left, this is 2. Nothing here is 1. So 2 plus 1, 3. So we have 3 moles at the left. Right, we just have these 2. So we have 2 moles at the right. So 3 moles at the left, 2 moles at the right. So now I told us, alright, in my previous video, please make sure you watch that video. Alright, so you increasing temperature favors the part with a lower mole, alright, with a lower number of moles, while increasing pressure, I meant pressure, increasing pressure favors the part with a lower number of moles, while decreasing pressure favors the part with a higher number of moles. So when you decrease pressure, it favors the part with a higher number of moles, or favors the part with a higher volume. Then when you increase pressure, it favors the part with a lower number of moles, or you can say it favors the part with a lower volume. So between 3 and 2, which one is smaller? 2. So increase in pressure will favor this direction. So that is why option A is the answer to this. Then the next question, if an equilibrium reaction has delta H greater than 0, something that has delta H greater than 0, it therefore means that that thing is going in the positive direction. 0 is the bridge between positive and negative. So take for example, I am counting from 4 downwards. 4, 3, 2, 1, 0. After 0, if I'm still moving down, what do I have? -1, -2, -3. So if delta H is greater than 0, so it therefore means we are going after 0, 1, 2. So greater than 0, 1, 2, +1. So it's going in the positive direction. If assuming they said less than 0, that means delta H is going in the negative direction. So greater than 0 means delta H is in the positive direction. So being the positive direction, it therefore means that the reaction is what? Endothermic, because delta H is in the what? Positive direction. So if an equilibrium reaction has delta H positive, that's what this greater than 0 means, so endothermic, the reaction will proceed favorable in the forward direction. So the reaction will go in the forward direction by A, high temperature, B, any temperature, C, low temperature, D, minimal temperature. Now, obviously, D is out of it and B is out of it. It's between high temperature and low temperature. Now, we are talking about the forward reaction. So in this case, delta H greater than 0, so that simply means delta H is what? In the positive direction. So therefore means that the forward reaction is endothermic and the backward reaction is what? Exothermic. So we are paying attention to the forward reaction. It therefore means that if you go to the general rule, high temperature favors endothermic reactions, low temperature favors what? Exothermic reaction. So the answer is not C, but rather the answer is what? Option A, high temperature. The next question, question 6. We have this 2SO2 gas plus O2 gas to give 2SO3 gas. Delta H is -395.7 kilojoules per mole. In the reaction above, the concentration of SO3 gas can be increased by, so how do we increase the concentration of SO3? So that means how do we favor the forward direction? The forward direction is what we want to favor, which is the production of SO3. Now remember, we have delta H minus, so therefore means that the forward is what? Exo, and the backward reaction is what? Endo. So it's clear that what we want to favor is what? The forward reaction. So remember, because it is exo, we must decrease temperature, because decreased temperature can only favor exothermic reaction. So we need to decrease temperature. So but now let's go through the options. Option A, the addition of catalyst. I told you, please and please, catalysts do not have effect on the equilibrium position of a reaction. So out of it. B, decreasing the pressure. C, decreasing temperature. D, increasing the temperature. Now, increased temperature will push the equilibrium position to the left, not this direction, to the left. So D is automatically out of it. Then we are left with B and C. B is decreasing the pressure. Decreasing pressure. Now, let's look at this. Remember, they are all gases. So now let's relate their number of moles. This is 2 plus 1. In total, at the left hand side, you have 3 moles. Now this is 2 here. So at the right hand side, in total, we have just what? 2 moles. So now, high pressure, increased pressure, favor the part with a lower number of mole. Decreased pressure favors the part with a higher number of mole. So if you decrease the pressure, it's going to favor this side. Why? Because this side has a higher number of mole, 3 mole. While this one has a lower number, which is 2. So 3 is higher than 2. So what will favor this direction is for us to increase the pressure. So but option B, we are having decreasing pressure. So decreased pressure will favor this direction, the part with a higher number of moles. So B is out of it. Automatically, C is the option. Even without analyzing all these things, from my explanation earlier on, exothermic. So you must decrease the temperature to favor what? Exothermic. So the answer is what? C, decreasing the temperature. Question 7. CuO solid plus H2 gas then gives solid. What is the effect of increasing the pressure on the equilibrium reaction? The effect of increasing the pressure on this equilibrium reaction. Now, increase the pressure cannot affect this equilibrium reaction. Why? Remember I told you, before you use the effect of pressure, you need to consider one simple thing, and that is to check through your reactant and your product Are all of them in the gaseous state of matter? Are all of them in the gaseous state of matter? If yes, then pressure can have effect. If no, pressure cannot have effect. So all of them are not in the gaseous state of matter. So this guy is a solid, this guy is a gas, solid, liquid. So they are not all gases. So therefore, pressure will not have effect. So increasing the pressure, sorry, this becomes the answer. Increasing the pressure will create no effect. So there is no effect on increasing the pressure of this reaction. No effect at all. No effect. So every other option is just out of it. The answer is what? C. There is no effect. Alright, question 8. I love this question. It says the equilibrium of an endothermic reaction which proceeds with increased volume can be shifted to the reverse direction. Very sensitive question. The equilibrium position of an endothermic reaction. So they told you that the reaction is endothermic, so delta H is positive. So this simply means that the forward reaction is positive and the backward is negative because delta H is positive. Now it proceeds with an increase in volume. Increase in volume. So therefore means that this guy has a higher volume. The forward direction has a higher volume, while the backward direction has a lower volume. So forward direction high volume, backward direction low volume. Alright, now with an increase in volume can be shifted in the reverse direction by, so how do you shift the equilibrium position to the backward direction? Not forward, they say in the reverse direction. So to this side, the left hand side. How do you put it to the left? Remember, let's compare. The forward is delta H is positive. The backward delta H is negative. So the backward is exothermic and the forward is what? Endo. Remember, they're asking us for the reverse direction. So exo, lower temperature, decrease in temperature will favor what? Exothermic reaction, decrease temperature. So you go with the option that has decreased temperature, alright? Then now for the left, you have low volume. For the right, you have high volume. So remember, how do you favor the part with a lower volume or a lower number of moles? Please take note, if they use lower volume, it's still the same thing as saying lower number of moles when it comes to using pressure, alright? So it's either you work with moles or work with volume, the same thing. Alright, so lower volume, or we can say lower number of moles. To favor lower number of moles or lower number of lower volume, we will have to increase pressure. Increase pressure favors the part with a lower volume or a lower number of moles. Decrease pressure favors the part with a higher volume or a higher number of moles. So the answer to this question becomes increase pressure for the low volume and then decrease temperature for the exothermic. So decrease temperature and increase pressure, that's the answer of A. That becomes the answer A. Decrease temperature for the exothermic and increase pressure for the part with a lower volume or lower number of. So option A is the correct answer to this question. And the next question, question 9. Look at this, 2H2 gas plus O2 gas to give us 2H2O gas. So hydrogen reacting with oxygen to give us steam. Then delta H is negative. What happens to the equilibrium constant of the reaction above if the temperature is increased? Oh my God, questions like these are very, very simple. Alright, if you have been following all the questions I've been looking at, this particular question 9, this one is operation look and pick your answer. Because saying delta H negative is telling us that this direction is exo and this direction is what? Endo. So if the temperature is decreased, what will happen? Obviously, the equilibrium position will shift to where? To the left. That is endo. So therefore means that okay, the equilibrium constant. Okay, so A, the equilibrium constant. Now the reaction is exothermic, but if we increase the temperature, if we increase the temperature is going to make the equilibrium constant not in the direction of the exothermic, but rather in the direction of what the endothermic. So, and when I was teaching about temperature, all right, in my previous video, I stated something about the equilibrium constant K. I made mention of the fact that for endothermic reaction, that is, if the forward reaction is endothermic, when you increase the temperature, what happens? The equilibrium constant also increases. So for endothermic reaction, increase, that is the forward reaction being endothermic, increase in temperature makes the equilibrium constant K to also increase for endothermic. But for exothermic, when the forward reaction is exothermic, increase in temperature will make the equilibrium constant K to decrease. But decrease in temperature, which favors exothermic reaction, will make the equilibrium constant K to increase. So for exothermic, decrease temperature, increase equilibrium constant. For endothermic, increase temperature, increase equilibrium constant. So the answer to this question, so when it shifts to the left, the equilibrium constant will do what? Decrease. Option D, decreases. So that's the answer. Then question 10, we have this H3PO4 plus H2 to give us H2PO4 minus plus blah 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 blah, and we have delta H is equal to what? Minus 13 minus. So it means the forward is exo and our backward is what? Endo. So in the reaction above, an increase in temperature would, so increase in temperature obviously is going to shift the equilibrium position. When you increase the temperature, it favors the endothermic part, so the equilibrium position is shifted to the reverse direction, or you say it's shifted to the left. So the answer simply means, the answer here is simply option B, favor the reverse direction. So the reverse direction is favored. Then question 11 says Cu2 plus 4H3. So give this, in the reaction above, what is the effect of precipitating Cu2 plus as copper sulfide, as CuS? So now, what is the effect of precipitating this guy? The precipitation has to do with something that is being removed, something that is removed out of a solution. So that's precipitation, is like you are saying taking out. So when you remove Cu2 plus, what will happen? Remember, removal from one part favors the same part. Addition to one part favors the opposite part. That's what it is. So option A, he said there will be no effect. That's wrong. B, the equilibrium position will shift to the right. No. Precipitation is not like you're adding. It's like something is leaving, is removing. Alright? So B is on. Then C is the correct answer. More NH3 will be generated. Then, of course, this is not the answer. So our answer to this question is option C. So removal of this causes an increase in production of what? This guy.